Hi students, this is Saheb sir, your chemistry mentor. Today we are going to learn about quantum numbers in atomic structure lesson. What is quantum numbers? What is the use of the quantum numbers? The numbers which give complete information about electrons, orbitals and subcells are called quantum numbers. Complete information about electrons present in orbitals in the atom. The information given by principal quantum number, azimuthal quantum number, magnetic and spin quantum number. Quantum numbers are four types. These are principal, azimuthal, magnetic and spin quantum number. First we go to principal quantum number. This explained by Niels Bohr. Niels Bohr. It explains size, energy, number and velocity of orbitals. Size of the orbital, energy of the electron, number of orbitals and velocity of electrons. It explains number, size, energy and velocity of orbitals. Okay students, it is the main feature. And values of principal quantum number is small n. It denotes by small n. Principal quantum number it denotes by small n letter. 1, 2, 3, 4. Already we know in Bohr's model, atomic model, we learned this one. Or K, L, M, N. Like this. With increasing of n values, size, energy of orbitals also increase. Size of the orbital increases with increasing n values. And if we know the number of orbitals, we calculate. How do we calculate number of orbitals present in a cell? That is n square formula. N is the orbital number. Okay, n square formula. How to find out the number of electrons present in a main shell? Number of electrons. That is formula is 2n square. Example K. First sub cell have 2 electrons. Second L cell have electrons. M cell have 18 electrons. L cell have 32 electrons. Like this we have calculated the electrons number in the cells using the 2n square formula. Okay, next second quantum number is azimuthal quantum number. It denotes by small l. Okay, Sommerfeld is introduced this quantum number to explain the fine spectrum. To explain the fine spectrum, Sommerfeld was introduced this quantum number. It also called orbital angular momentum quantum number. Orbital angular momentum quantum number are also called secondary quantum number. Secondary quantum number. What it explains? It explains shapes of orbitals. Shapes of orbitals. S orbital spherical shape, p orbital dumbbell shape, d orbital dumbbell shape, f orbital is not determine the shape. That like orbital shapes explained by azimuthal quantum number, and also explains number of subcells present in a cell. Number of subcells present in a cell. Shapes of the orbital is important in this picture. Okay, what is values? Like these also some values. Values is L is equal to n minus 1. What is the n? Principal quantum number. N minus 1 is the equal to L value. These L values always 0 to n minus 1 and are total equal to n number. Okay students, total equal to number of n. Okay, take example. N is equal to 1, 2, 3, 4. We know that. How the L values? N minus 1. L is equal to 0, 1, 2, 3 like these. What is 0 if L value is s orbital? It's fixed students. That is 1s, 2s, 3s, any s orbital, that L value is 0. P orbital value always 1. That is L value of P orbital is 1. D orbital value of L is 2. F orbital value of L is 3. Like this. Okay students, and abbreviations of sp, df orbitals is S means sharp, P means principal, D means diffuse, F means fundamental. This is the abbreviations of SPDF, and their shapes are spherical, dumbbell, double dumbbell, not recognized. Okay, F orbital shape is not recognized, not determined also. And next, magnetic quantum number. The source denotes by small m. Okay, introduced by Lande. The scientist Lande, to explain Zeeman effect. Okay, students, it explains about orientation of orbitals on their axis. Orbitals are nothing but cloud of electrons. The electrons are always moves around the nucleus. Where the orbitals found, that is known as orbital. In their axis, that orbitals, where orbitals are present, are known, explained by magnetic quantum number. Values of magnetic quantum number m is equal to 2l plus 1. What is L, students? L is nothing but azimuthal quantum number value. Okay, what is the formula to identify the m values? 2l plus 1. It also explains number of orbitals present in a subcell. Okay, these are the orbitals. S, P, D, F. S is only one orbital. That value of m is equal to 0. Total how many orbitals? 1. So m is 1. Next, P is equal to 3 orbitals. That is Px, Py, Pz. Okay, students, Px, Py, Pz. How to show m values? The middle one is 0, right side 1 plus 1, left side minus 1. Like D have 5 orbitals. That is dxy, dxz, dyz, dx square, y square, dz square. Like this, middle one is 0, right side 2 or plus 1 plus 2, left side or minus 1 minus 2. Sorry, this one is minus 1, this is minus 2. Minus 1, minus 2, minus 3. Okay, students. Next, f orbital have 7 orbitals. F cell have, that is 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Like this, m values are depends on L values. That is 2L plus 1 formula. We calculate the m values. Okay, students. Next, spin quantum number denotes by small s. Introduced by Uhlenbeck and Goudsmit. Uhlenbeck and Goudsmit. The electrons rotates around the nucleus with their self spin. Electron rotates himself and also rotates around the nucleus. That spin have two directions. That is clockwise direction and anti-clockwise direction. That clockwise directions have value plus of, anti-clockwise value is minus of. We are showing in upper arrow mark that clockwise direction and lower arrow mark of anti-clockwise direction. This is clockwise direction spin, this is anti-clockwise direction spin. What is the use of spin? They have, if one orbital have 2 electrons, plus of and minus of, total value is 0. That's why the atom is neutral, because of total charge of the electrons comes to 0 at the end. If only single electron present, that have plus of or minus of charge, that is chargeable particles. Okay, students, in the spin angular momentum of electrons, to find the formula is mu is root s into s plus 1 h by 2 5. Okay, students, root s into s plus 1 h by 2 5. Okay, students, these are the quantum numbers. To overall quantum numbers, 4 quantum numbers, very useful for intermediate public examinations, very important also, 8 marks in 8 mark section. All these are explained in a single diagram once you look at this. Okay, students, this is the diagram to explain the quantum numbers. These are the atom, students. This is nucleus, you know. These are the orbits. Circular paths are orbits where electrons are rotating. These green orbitals are 1s, 2s, 3s, 4s. These are values k, l, m, n. N is equal to 1, 2, 3, 4. These are the orbits. also known as principal quantum numbers. N is equal to 1, 2, 3, 4. In these, in first cell, this is 1s orbital. In second cell, 2s, third cell, 3s, fourth cell, 4s. Have singular boxes. In these, 2 electrons are filled. Okay, this m value is 0. Where the n value is, these are the n values. What is the s value? S value always s is equal to 0. L value always for s 0. M values are, what is M values? Also 0 for s orbital. And otherwise in second orbit there are present p, 2p, in third 3p, in fourth 4p. Okay students, 4, 2p, 3p, 4p. Every p orbital have 3 orbitals that are px, py, pz. Px, py, pz. Okay students, the p value for n value for 2, 3p, it is the n value. This is the n value. P value, L value for p orbital is 1. We also know. And px, py, pz. This middle one is 0, right side one plus 1, minus 1. This is the m value. How do we show the spin? Spin if upside, plus of. If lower side, minus of. Every electron, that is it. Next, in third cell, what we enter? 3d. D orbital enters in third cell. The 3d has dxy, dxz, dyz, x square, y square, z square. These magnetic values are 0, minus 1, minus 2, plus 1, plus 2. This is the magnetic quantum number values. And also in fourth cell, what enters? F orbital enters. These have 7 orbitals. This is 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Azimuthal value, magnetic quantum number values. Okay. Once we look at the how to we identify the quantum numbers in an by electronic configuration. We are taking an example 3p3 electronic configuration of last electronic configuration of one atom. Where the first letter 3 number is the principal quantum number, n value is 3. What is the L value? Next, n is complete, n is equal to 3, L is equal to, m is equal to, s is equal to. How do we identify? N is equal to 3. What is p? P value always 1 for L, azimuthal. So 1. P value is 1 for L. And out m value how do we show? 3. 3 means 1, 2, 3. 1, 2, 3. So plus 1. This is minus 1. This is 0. This is plus 1. Like that. Minus 1, 0, plus 1. Like this one 3, 1, 2, 3, plus 1. That's why m value is plus 1. What is the spin? Spin upside the, we show the plus of. So this spin is the plus of. Like this, all electrons of atoms, we can have 4 quantum numbers values, like we find out the quantum numbers. Okay students, thank you. Please pause the video and note down. Also the structure if you are usable. Okay students, pause the video. Please pause the video and note down. Very important for IPE exam. Thank you students. Like J&D, like it, share and subscribe the channel. Thank you.